So we have this nice little formula that says that the amount of whatever we earn is equal to P sub 0, which means that's how much we had at the beginning before we've done anything, times E. And E is just a number like pi. It's 2.71 something, okay? And we raise it to the rate. Well, sometimes, actually in this book, they call it K, not R, but it means your rate times the time, which is usually in however many years it takes. Okay, so that's the main formula that we're kind of working with on these problems. So here's what I know about this. This says that country A, I'll just kind of come down here and write down country A, and we've got country B. So for country A, we know that we have a growth rate, or the same thing as K, and we know that it's 1.2% per year. That's kind of what I know. On country B, I know that the doubling time, I'm just going to say DT, doubling time is equal to 26 years. So they're wanting me to find out the missing part. So on this one, on country A, they're saying, well, given this information, that the rate is 1.2% per year, tell me what the doubling time is. Okay, so you kind of need to wrap your mind around what doubling time means. Doubling time just means what it says. How much time does it take the money to double? So if I put $5 in the bank account today, and I was looking for the doubling time, I'm looking for how much time it takes for me to get $10. Okay, I'm just looking for how much time it takes for it to double. So if we use this formula that we had, we would say, okay, we're starting out with P sub 0. We don't know that, how much money we're starting out with, times E raised to the K. Now we do know K. K is this rate per year, but you can't put it in as a percent. You have to put it in as a decimal. So to change a percent to a decimal, you would do 1.2 divided by 100, and that would give you 0.012. So that's what you would put in the formula for K. And then we don't know T. T is what we're trying to find. How much time does it take to double? Okay. So if this is the amount that I put in, P sub 0, okay, let's pretend it's $5. And I want to know how much time it's going to take to double, then I want to know when the amount is 2 times whatever I put in to start with. Are y'all okay with that? I want to know what the amount is after it's 2 times whatever I put in there. So I'm going to say 2 times P sub 0. Because in your original equation up here, you've got the amount is equal to this. Well, I want to know when the amount is twice what I put in. So that's why I let the amount be 2 times P sub 0. Is everybody okay with that? So after I do that, this is going to go pretty quick. I can get rid of P sub 0 altogether because I've got a P sub 0 on both sides. So that would just cancel out. If I divide by P sub 0, I would get 2 is equal to E raised to the 0.012 T. Okay. Everybody good with that? All it is divide out that P sub 0. Now, I need to figure out what T is. So that means that I need to get this T moved down. And we can use that power rule where if we take the natural log of both sides of our equal sign, that power rule says that you can move this exponent down front. So you say the log of 2 is equal to 0.012 T natural log of E. The natural log of E is 1. So you can just mark it out because we're just multiplying by 1. Natural log of E is just going to come out as 1. So now I'm really close. If I divide both sides by 0.012, I'm going to get my answer that the natural log of 2 divided by 0.012, I want to make sure that we're rounding correct. I'm going to get 58. It's going to take 58 years. And they say to round it to, let's see, round doubling time to the nearest whole number, and round the growth rate to the nearest tenth. Okay, so 58 years is going to be the doubling time. If my my growth rate is 1.2% per year. Okay, country B, we have different information this time. We don't know what the rate is. That's what we're looking for. So we would say, well, I'm putting some money in the bank. The money I put in is P sub 0 times E raised to the K, which we don't know the rate, but this time we do know that the time is 26. I'm still looking for how long it's going to take this thing to double. So I'm still wanting to know, when does my initial amount double? When I multiply it by 2. Same principle here. So I would get rid of that P sub 0 on both sides of my equal sign. And I'm going to get 2 is equal to E to the, and I'm putting a 26 in front of the K, 26K, just because I'm used to seeing it that way. It doesn't have to be that way, but it just to me looks nicer. If I want to figure out what K is, I'm going to have to move it down. So I'm going to use that power rule that says that if I take the natural log of both sides, that means that I can move this 26K down front. The natural log of E is just 1. So you really don't need it there. So we really, to find K, we just need to divide by 26. And if we round it to 1 decimal place, we're going to get 2.7. And actually, I don't think that's what, you're going to get a decimal, and then you're going to have to make it into a percent. So let me type this in the calculator. So natural log of 2 divided by 26. Okay. So I told you a falsehood, kind of, sort of. So K is equal to 0.02665, and it keeps going. So I need to take that number and multiply it by 100, which is going to give me 2.665, which would round to 2.7. Does that make sense? It's going to give you a decimal, and you have to change it back to a percent, because they're saying, what's the percent? Questions? Number 3 says, suppose that $15,157 is invested at an interest rate of 5.8% per year, and that it's compounded continuously. When it's compounded continuously, that means like every second of every minute, right? It's compounding. So that's why we're using that E. It's a very good, I guess, approximation at what the answer is going to be. So they want us to find the exponential function that describes the amount after the amount in the count after T time in years. So that's that whole thing where you say P sub 0 is, you say A is equal to P sub 0 times E raised to the KT. Well, how much money did we have in the account to start with? They told us 15,157. So that would be our P sub 0. The next thing is an E. That's a number, just like pi. It's 2.7 something. K is supposed to be the rate, and our rate is 5.8%, but you don't put in the percent. You have to put it in as a decimal. So you're going to divide by 100 and get 0.058. And then time is the number of years, so we would put a T there. So that's our equation. And here's what I'm noticing. They're asking me for several different years: 1 year, 2 year, 5 years, and 10 years. And they're saying round to 2 decimal places as needed. Okay, so I could easily go to my calculator and plug in 1 the first time, plug in 2, then plug in 5, but it would be much easier if I just did a what? I gotta use that table if you've got a whole bunch of them on your calculator. So we could go to our graphing calculator and we could get the answers by going to y equals. So 15,000 157 times E, and E is second ln raised to the 0.058 t, and we don't have a t, so we just use an x for that. So I've typed in my function. Now I can go second table, and they want to know what 1 year is, and it says to round to 2 decimal places. So when you go over here and you go over to it, you see that you can see it's $16,062.10, but you have to go over to it to not see the whole number. So then I would scroll down and go, well, what is it at 2 years? It's $17,021.24. And then they want to know 5, 20,256.23, and then 10. So we would scroll on down and get that value. I just feel like using the graphic calculator does kind of help you not make so many mistakes, but you're going to have to go over and highlight it to get the extra 2 decimal places. Okay. So here's what the calculator came up with. $16,062.10. Yes, sir. And okay, so everybody good with that part? So then it wants to know, well, how much time is it going to take to double? Well, here's what we had in the beginning. So the first thing we need to do is say, well, what is 15,157 times 2? So that would be how much time, or that's going to be that's our goal, what we're looking for. Okay, I'm getting 30,314. That's how much I would have if I had double that amount. Okay. So what I'm looking for is, when is that equal to 15,157 E? I'm just using my function that I had a while ago. But I can kind of use my calculator to kind of check myself to see if I can't get the exact answer because it says round to 1 decimal place, but I can get pretty close by looking at my table and saying, well, when is it about 30,314? So I'm looking in this Y. It does look like it's between 11 and 12. It looks like 11 is not enough, but 12 might be too much, right? So we know that whatever we find should be somewhere there. Okay, so I'm going to okay, so I'm going to solve this problem. First thing I'm going to do is divide by 15,157. Well, that should be 2 because we just doubled it. We've got something raised to the t power, which means that we're going to have to take, and I'm taking the natural log because I'm using this E instead of the regular log. When you see an E, you always want to use natural log. It just makes your life easier. So we've got the natural log of 2, 0.0, we're using that power rule to bring this down front. 0.058t is equal to the natural log of E. Natural log of E is 1. It can just cancel out. So 0.058. When we do this, it's going to tell us how much time it takes. And it's saying 12. Actually 12.0. So we know that based on our calculator answer, we said somewhere between 11 and 12, and on ours it said 12 was too much, but apparently when you type it in, let's see what we got. I mean, we are rounding here, so that goes into play. This, yeah, this, when you type in the calculator, you get 11.95, which we said 12 was too much, so it is too much, but when we round, we're getting 12, okay? So round to 1 decimal place, 12.0 years. Okay, the data in the table shows the percentage of adults in the country who are currently married as declining, assuming that the percentage of adults who are married will continue to decrease according to the exponential decay model. Complete these parts. So the first thing they want us to do is to use the data from 1960 to 2012. So we are talking about this to this. What is, so we're always working with this formula. A is equal to P sub 0 times E to the KT. That's the formula we're using. So what's the percentage of married couples in the beginning of this table in 1960? 70.8. E, K, we don't know that. That's what we're looking for. They said find K. Well, we're supposed to use from 1960 to 2012. So we should be able to figure out, well, how much time has gone by from 1960 to 2012 by subtracting 2012 minus 1960. And that's going to be 52 years. Okay, at 52 years, what's the amount that we ended up with? The percent that we ended up with was 41.2. Okay, do you understand where I came up with this stuff? So the amount, the A is supposed to be the amount at the end, the P sub 0 is the amount at the beginning. So now I'm going to solve for K. So I'm going to divide both sides by 70.8. I'm trying to get to that K. So we've got 41.2 divided by 70.8. I'm getting, and you on these, you want to write down as, I know that the calculator is rounding, but you want to try to write down as much as you can to save yourself from any rounding errors. And I'm going to put the 52 in front of the K just because I like it that way. Okay, you don't have to if you don't want to. I know that I've got to get that K to move down front. So I'm going to have to take the natural log of both sides. So I can use that power rule so that the natural log of 0.58192 is equal to 52 times K times the natural log of E. Get it to move to the front. The natural log of E is 1. That can just go away. So you're going to divide by 52. Yeah, it's negative 0.010411, and it keeps going. That's going to be K. Why is my growth rate negative? It's going down. That's right. When you put your answer up here, do not put the negative. I'm going to write really big. Do not put negative. So you're supposed to leave the negative part off when you put down what K is, and it says to round to 4 decimal places. So 0.0104. When you put your answer here for K, you do put the negative. And I don't know, to be honest with you, I don't understand why they don't consider it negative there too. But for some reason they don't. So we're just gonna, because right here it's negative. Makes no sense to me. But when you're doing your homework, there's a trick. Don't put negative. We started out with 70.8. So this is our formula. This is what we started out with. So P sub 0 times E raised to the negative 0.0104 times however many years it took. So it says, estimate the percent of adults who are married in 2015 and 2018. In 2015, how many years have gone by since 1960? Because that's what T is going to have to be. Okay, so you want to do 2015 minus 1960. And I'm hearing 55. In 2018, Yes, that'd be 58. So 2018 minus 1960, it's gonna be 58. So your choices are to go to your calculator if you want to and put this formula in and find 55 and 58. It does want you to round to one decimal place, or you can just plug in for T, you can plug in 55 and 58 to find the answers that way. It doesn't matter, whichever way you want to do it. So if we went to our graphing calculator, I mean, we've got two of them, so I just would rather type it in once instead of twice. So we've got 15,000, nope, wrong. 70.8 times E to the negative 0.0104x. So then I can go to my table and I'm gonna have to scroll way down to 55. It says that 55 is 39.959. And they want me to round that to one decimal place. So that would round up to 40. And 58, 38.732. So it's going to be 38.7. At this rate, it's this decay rate, in which year will the percent of adults who are married be 32%? So I can't get the whole answer from my graphing calculator, but I can go, okay, 32%. It's not 32% yet. I'm looking. Yes, I'm sorry, I went too far. So 76 and 77, sometime between those 2 years, it's going to happen. So if I get something else, I know I did something wrong. So we're asking, when is our formula, our 70.8, this formula that we came up with in the beginning, when is that going to be equal? Okay, so I would divide by 70.8 on both sides. 32 divided by 70.8 is 0.451977 ... equals E to the negative 0.0104t. You want that variable to come down, so you're going to have to take the natural log of both sides. You can use the power rule to get that to come down the front. The natural log of E is 1. So we really just need to divide by negative 0.0104 on both sides. Okay, and when you do that, you're going to get I'm getting like 76.35, and they're wanting us to round it to, says round your answer to the nearest whole number. Okay, so I'm getting 76.35. That's not the answer. We do know on our graphing calculator it was between 76 and 77. But this number means how many years have gone by since 1960. Okay, so you're going to have to go, well, what is 1960 plus 76? That's how you get 2036. Questions? The number of farms in a certain state has declined continually since 1950. In 1950, there were 83,672 farms. In 1995, that number had decreased to 29,720. Assuming that the number of farms decreased according to the exponential model, find the value of K and write an exponential function that describes the number of farms after time T, where T is the number of years since 1950. So basically, we know that in 1950, we had 83,672 farms. By 1995, we are down to 29,720 farms. Okay, so our model A is equal to the principal times E times the rate, which is they write K, not rate, KT. Okay, well, A would be the amount I have right now, which is 29,720. I started out with P sub 0, which is 83,672. I don't know what that K is. I'm trying to find that, but I do know what T is, because T would equal the amount of time that has gone by from 1950 to 1995, which is going to be 45 years, right? So we would put a 45 for T. Does everybody understand where we came up with that formula? So now I would want to, I'm trying to find out what K is. I'm going to divide both sides by 83,672. .35519, it keeps going, is equal to E. And I'm just putting the 45 in the front because I like it that way. So now I would take the natural log of both sides. That's the only way I can get that K to move down front. I'm gonna get the natural log of 0.35519, keeps going, is equal to 45K. Natural log of E. The natural log of E is 1. So when I divide this by 45, I'm gonna have K written as a decimal. So it's giving me negative 0.02300. Don't forget that this is written as a decimal and it wants it as a, well, actually, we don't have to find that because we can just write down. They've given us the formula, so we don't have to do the other work. Okay, so we're good. Which one is it? D? Negative 0.023. Yeah. All those numbers are pretty close together. So you want to make sure you don't, don't write down too few numbers, because if you round wrong, it'll cause you problems. We already worked 6 and I'll post that video. But that is homework help.